friends, welcome to our mathematics program for grade 8. Today we are going to look at polygons, right? Now, the chapter polygons you have already seen in grade 7. What did you learn in grade 7? Well, in grade 7 we've seen how to identify and name polygons. We've seen together how to differentiate between scalene, isosceles and equilateral triangles. We've seen together how to differentiate among the different types of quadrilaterals and how to find unknown angles in triangles and quadrilaterals. Now, if these are not clear for you, please go back to your notes, okay? Now, what are we going to learn in grade 8? Well, in this video, we are going to see together how to identify and determine the interior angles of polygons, right? And secondly, we are going to solve problems involving regular polygons. So let's start. Now, what is a polygon? A polygon is simply a closed, flat shape with many sides. Be careful here. It needs to be a closed, flat shape, right? Let's take a few examples. This, you've seen a triangle. A triangle, it is closed and it is flat and it has 3 sides. That's a quadrilateral and you've got an hexagon. Now, these are all closed, flat shapes, right? Now, let's see. These two figures are not considered to be polygon. Why? Well, in the first one, you see that curve shape, right? A polygon does not have any curves. And what about the second one? Well, the second one is not closed. Right. Where can we see polygons? Now, the first one, right, you've seen that. How many sides do you have? Well, 5 sides. 5 sides, if you recall, it is called a pentagon, right? And the United States Defense Department, it's called the Pentagon. Then we can see polygons in architecture and in road signs. That's the stop sign. Now, how many types of polygon do we have? Well, we have mainly 2 types of polygon. These are regular and irregular polygons. What do we mean by that? Regular polygons, all the sides are equal and all the angles are equal, right? For example, here that's a pentagon, a regular pentagon. All the sides and all the angles are equal. Secondly, irregular polygons. Now, irregular polygons, the sides are of different length and the angles are of different sizes. For example, here, you see that the length, they are not the same, they are not equal, right? Same for here and the last one. Now, remember, regular, sides equal, angles are equal. Irregular, the sides are of different length and the angles are of different sizes. Simple, right? Now, we've said that we're going to learn about interior angles. What do we mean by interior angles? Now, the interior angles of a polygon are the angles formed inside the polygon. That's what we call it, interior angle, where the 2 edges meet. Right, let's see an example. This is simple triangle, right? You've seen these 2 edges and the angle. That's what we call the interior angle. Now, let's say that we want to find the sum of all the interior angles. How are we going to do that? We'll start with the simplest polygon that you know. That is a triangle, right? So this is a triangle. Now, you've learned that since primary We know that when we add all the angles of a triangle, we have 180 degrees. That's right. The sum of the interior angles of a triangle is 180 degrees. All the polygons will be based on that, right? So if you need to learn something, it is the sum of interior angles of a triangle is 180 degrees. Okay, let's start with something a bit higher now. Let's consider a polygon with 4 sides. That is a quadrilateral. Right. Simplest one, that's a rectangle. Okay, what can we do with that? Well, we can divide this rectangle into 2 triangles. Exactly. And what do we know? Well, we know that for a triangle, the sum of angles is 180 degrees. Right? So we have 2 of them. So in this quadrilateral, we have 2 triangles. Therefore, the sum will be 2 times 180, which is 360 degrees. If we consider now a 5-sided polygon, that is the pentagon, right? Okay, can we divide that pentagon? Yes, we can. Like this. How many triangles are we going to get? Well, 1, 2, and 3. That's 3 triangles. And remember, the sum of angles of a triangle is always 180 degrees. So, you've got 3 of them. So that will be 3 times 180 degrees, which is 540 degrees. Right? So in this pentagon, the sum of interior angles will be 540 degrees. Let's consider now a 6-sided polygon. Remember, how do we call a 6-sided polygon? That's a hexagon. So in this polygon, let's divide it, right? How many triangles can you see? 1, 2, 3, 4. That's 4 triangles. And remember, the sum of angles always 180 degrees. So, what do we need to do to find the sum? Well, simple. We take 180 degrees and we multiply by 4. Why do we multiply by 4? That's because we have 4 triangles. So, the sum of interior angles of this hexagon will be 720 degrees. Right. What can we deduce? You're not going to draw triangles each time, right? Well, we can see that we have 2 triangles less than the number of sides. Okay? So if we have a triangle, number of sides is 3, and the number of triangles will be 1. A quadrilateral, number of sides, 4, that's what we have seen. Number of triangles is 2. Pentagon, number of sides, 5. Number of triangles, 3. Hexagon, number of sides, 6. And number of triangles, 4. Let's see another example. What is the sum of the interior angles of a 12-sided polygon? Well, how do we do that? We could draw the triangles in the polygon, or in simpler way, we know that number of sides, 12, right? So the number of triangles is always 2 less than the number of sides. So that's 12 minus 2, which is 10. Therefore, we can say that the sum of interior angles will be 10 times 180, which is 1800 degrees. Right? So let's generalize something. The formula for the sum of interior angles, well, we say that for a polygon with n sides, the sum of interior angles is given by n minus 2 times 180 degrees. I say it again. For a polygon with n sides, the sum of interior angles is given by n minus 2 times 180 degrees. Example 1. Now, suppose that you need to find the sum of the interior angles of a polygon with 14 sides, right? Simple. What do you need to do? Well, we know that here the number of sides is 14, right? So the sum of interior angles, if we use the formula, it's simply n minus 2 times 180 degrees. So what is n? n is 14. So that will be 14 minus 2 times 180 degrees. 14 minus 2, you know that it is 12. And 12 times 180 degrees is 2160 degrees. Simple. Let's take another example. Example 2. Find the sum of the interior angles of a regular polygon with 22 sides. Now, you're not going to draw triangles with a polygon of 22 sides, right? So what do we need to do? You use the formula. Now, what do we know? We know that the number of sides, that is n, is 22, right? So the formula is the same for regular or irregular polygon. So we're going to use the formula. The sum of interior angles is n minus 2 times 180 degrees. So that will be 22 minus 2 times 180 degrees, right? So that's 20 times 180 degrees, which is 3600 degrees. Example 3. Find the size of one interior angle of a regular hexagon. Here you need to be careful, right? Why? Because I don't want the sum. I want the size of one interior angle. How are we going to do that? Well, we know that it is an hexagon. The hexagon has 6 sides. That's right. So the sum of interior angles will be n minus 2 times 180 degrees. That is 6 minus 2 times 180 degrees, which is 6 minus 2 is 4. And 4 times 180 degrees is 720 degrees. So 720 degrees represent the sum of all the interior angles, right? Now, I want to find one interior angle. So what do we need to do? Now, since it is a regular hexagon, we know that if it is regular, all the sides and all the angles are equal, right? So here, if all the angles are equal, what do we need to do? Simple. 720 degrees divided by 6, which is 120 degrees. Example 4. We need to find the value of x in this polygon. Now, remember, here we have 4 sides and 4 angles, right? Now, if we have 4 sides, how do we call that? That is a quadrilateral. So how are we going to tackle it? Now, we know that the number of sides is 4, right? So the sum of the interior angles will be n minus 2 times 180 degrees. That is 4 minus 2 times 180 degrees, right? Which is 360 degrees. So what does that mean? It means that when we add all these angles together, we are going to have 360 degrees. So that will be x plus 65 degrees plus 90 degrees plus 120 degrees is equal to 360 degrees. So what do we need to do? You simplify it. You will get x plus 275 degrees, which is equal to 360 degrees. And you solve it, right? You will get x is equal to 85 degrees. We take another example. Now, find the value of x in this shape. Right. So what do we need to do? Well, let's count the number of angles. How many? Number of sides and number of angles. They are 6. Right? So if we have 6 sides, the sum of interior angles will be 6 minus 2 times 180 degrees. That is 4 times 180 degrees, which is 720 degrees. Right? What do we need to do now? Remember, we need to find x. So when we add all these angles that you can see here, you're going to have 720 degrees. Let's write this equation. So 165 degrees plus 2x plus 130 degrees plus 95 degrees plus 3x plus 110 degrees equal to 720 degrees. We simplify it. We're going to have 5x plus 500 degrees, which is equal to 720 degrees. What do we need to do? Well, 5x will be 720 degrees minus 500 degrees, which is 220 degrees. Now, be careful. Some students, they leave the answer like this, but you were not asked to find 5x. You were asked to find x. So what do we need to do? Well, you divide 220 by 5, which is 44 degrees. Example 6. Find the number of sides of a regular polygon whose interior angle is 140 degrees. How are we going to do that? Well, we know that one interior angle is 140 degrees, right? And we know that the sum of interior angles, that's equal to n minus 2 times 180 degrees, right? So, since in this example, we have a regular polygon, and we know that if it is regular, all the sides and all the angles are equal, right? So, one interior angle will be n minus 2 times 180 degrees, and you divide that by n, right? And we simplify it. We shall get n minus 2 times 180 degrees divided by n, which is equal to 140 degrees. So, we simplify. N minus 2 times 180 degrees equal to 140 degrees times n, right? You remove the brackets. 180 degrees times n minus 360 degrees equal to 140 degrees times n. You get all the n together, so that will be 180 degrees times n minus 140 degrees times n, which is equal to 360 degrees. Simplifying, you will get 40 degrees times n, which is 360 degrees, and n will be equal to 9. So, this polygon has 9 sides. Now, these are a few exercises for you to practice. Question 1. Find the sum of interior angles of a nonagon, an octagon, a polygon with 17 sides, and a 32-sided polygon. Question 2. Find the size of one interior angle of a regular polygon with part A, 10 sides, part B, 18 sides, part C, 40 sides. Question 3. In each of the following figures, which are not drawn to scale, find the value of x. You've got 2 of them here. Question 4. In each of the following figures, here again the figures are not drawn to scale, you need to find the value of x. Question 5. Find one interior angle of a regular dodecagon. Question 6. The interior angles of a heptagon are x, x plus 30, x minus 35 degrees, x minus 60 degrees, x plus 25 degrees, 2x, and x plus 60 degrees. You need to find x. Question 7 is a bit different. The interior angles of a hexagon are in the ratio of 1:2:3:5:6:7. And you are asked to find the difference between the smallest and the largest angles. Question 8. One of the interior angle of a polygon is 240 degrees and each of the remaining angles is 120 degrees. You are asked to find the number of sides of this polygon. Now, you've got two links that you can use for reference. Right, what have we seen today? Well, we have seen how to identify and determine the interior angles of polygons, right? That was our first objective. And then we have seen together how to solve problems involving regular polygons. Okay, so what do you need to do now is to work all the exercises found in this video and to work the exercises in your textbook. Okay, so until we meet again for the second part on polygons, it's goodbye for now.